I just wanted you to see what the up against here. So here's number 3. You want the augmented system. You put in the 24, 27, 40, 46, which will be different for you. So first you want to write down the coefficient matrix in the B so that you know what goes in here. Then you want to take the it's really hard to do this with a cat sitting in front of you. But then you want to take that copy and then run it into Mathematica. And I'm going to actually ask you to, as much as possible, to do this on Mathematica. The more practice you get, that, you know, that's one of the things we've seen in the past as being a failure, is not being able to, I'm going to call this OG so that it's very clear. In this case, I'm going to have a 2 by 2, but I have the B vector too, so it's still 2 rows, but it's going to be 3 columns. So that's going to go in here. So that's my augmented matrix. And I'm going to put the parentheses around there, and I'm going to put in 24, 27, and then 195, and then 40, and then 46, and then 342. And then Shift Enter. And then I'm going to row reduce. The command is row reduce, and then put in aug. And then if we display that as a matrix, you get this matrix over here. If you notice, you have a better memory than me, what that means is that this is what they have here. So that's when they row reduced, they say this row reduced already, that's what they mean, that they ran it on Mathematica. From here, you can extract the first column. So you either are putting an system of equations into augmented form, or you're extracting them back out. So if I extract back out, I get 1 times x1 plus 0 times x2 is minus 11, and 0 times x1 plus 1 times x2 is equal to 17. So that's what goes in here. So that's exactly how to do this problem.